Hi guys, today we're going to work on multiplying radicals. This is lesson 3, which I had gone over with you in class yesterday. So it's all the same information. I'm not adding anything new. When you multiply radicals, you can multiply any radicals together. So you don't need like terms, just like in with algebraic expressions, you don't need like terms to multiply them. So if I were to multiply, for example, the square root of 8 times the square root of 12, I would multiply them together and get the square root of 96. But then you have to remember to simplify that. So 16 is a factor of 96. So you would factor that into 16 times 6. And then since 16 is a perfect square, you take its square root and 4 goes on the outside. So 4 radical 6. Now if you notice in the beginning of the problem, you may have noticed that the square root of 8 and the square root of 12 could have each been simplified first. So if you wanted to, and you noticed that, you could have simplified them first. So the square root of 8 is the square root of 4 times 2. So that becomes 2 radical 2. And the square root of 12, 4 goes into that. So that would be 2 radical 3. And then you could multiply those. Now when you multiply, when there's a rational number on the outside, the rational numbers multiply together. So 2 times 2 is 4. And the irrational numbers, the numbers under the square root, multiply together. So that would be the square root of 6. Same answer, just it's your option. If you can, you might want to simplify first. Okay, but you can't always simplify first. So here's another example for you guys. Let me scroll down here. Okay, example 2. Let's say I gave you the square root of 3 times the square root of 15. So here you don't have the option of simplifying first. You have to just multiply. So you end up with the square root of 45. And then you just have to remember to simplify at the end. So think of what perfect square goes into 45. Well, 9 goes in. So this is the square root of 9 times 5. Take out its square root, which is 3. So 3 radical 5 is your final answer. Okay. You're going to see distributive property. Be careful. A lot of times with the distributive property, you'll see problems that look like this, where you have, not letting me scroll. Example 3. If the number on the outside is a rational number, like 9, and then inside here you might have the square root of 5 minus 2 times the square root of 7. So remember that the rational numbers multiply together. So the 9 is not going to multiply with what's under the square root. It's going to multiply with the invisible 1 in front. So this will give you, when you multiply, it'll give you 9 radical 5. And then when you distribute it to the second term, it's only going to multiply with the rational number on the outside. So it'll be minus 18 radical 7. And then you look to see if you could simplify. You can't. So that's your final answer. Okay. And then you'll see problems where you're squaring a radical. So let's say I had like 2 radical 5 squared. That means you're multiplying it by itself. So you're multiplying 2 radical 5 times 2 radical 5. And for these problems, you're going to notice something happen. So when you multiply the outside rational numbers, 2 times 2 is 4, and then times, and when you multiply the square root of 5 times the square root of 5, you get the square root of 25. And you'll notice that the number that you get in this square root is always going to be a perfect square because you multiplied the same square root by itself. So it'll be a perfect square. And so you have to take its square root, and there won't be any radical in your answer. So your final answer will be 4 times 5, which is 20. No radical in my answer because there's no irrational part because the square root of 25 was a perfect square. So you'll also see situations like that, and you can take a shortcut. The shortcut is if you see the square root of 5 times the square root of 5, you could skip to the answer, which is just 5, because the square root of 25 is 5. Or if you saw any square root times itself, the square root of 10 times the square root of 10 is just 10, because it's the square root of 100, which is 10. Another, just to show you a bunch of them, a square root of 9 times the square root of 9 is just 9. Well, I picked a perfect square, either way, okay, because you get the square root of 81. So you can pick some random weird number. The square root of 321 times the square root of 321 is just 321. Okay, or you could take the in-between step and actually figure out what that product is and then take its square root. So you have some of these to do tonight for homework, and I'll see you guys on Monday. Have a nice weekend.